Hi, I'm Christian. Welcome to my session about GitOps on Azure. This session is part of the Azure Back to School format, so thanks to the Azure Back to School team for organizing the whole event. Today you will learn how to host your application on Azure Kubernetes Service with ArgoCD and the GitOps approach. Today, almost every company is a software company. Most companies use software in their daily business to solve problems or produce own software to be more efficient and drive innovation. Especially in our global world, almost every company uses software to communicate and to collaborate across the globe. Software has changed on a regular basis and new functionality is added almost every day. Security updates are applied to make the software more secure, and if something did not work out as planned, bugs have to be implemented so that the software is working again. But the question is, how do these changes get into production and in the software product? So how does this software factory actually produce software and ship it to the customers? I am Christian. I studied computer science at the Technical University of Munich. I have experience working at my own startup, which did natural language processing before all the LLMs took over. I worked at Microsoft as a cloud architect with B2B software companies. I helped them optimizing their cloud architecture, applied best practices around development in Azure, and also optimized their architectures. Currently, I am supporting my customers on their Azure journey as a freelancer, so I am planning and implementing cloud architectures, mostly with infrastructure as code technologies like Terraform. So what is the agenda for today? I first give a high-level introduction about what actually Kubernetes is. Then I will share how you can run Kubernetes in Azure. And then we go to the most important part. What is GitOps? How does a GitOps process look like? And how can we actually implement it using ArgoCD? Last but not least, I will showcase everything in a demo setup with a demo application. So let's jump right into it. So what actually is Kubernetes? Let's take a short travel through history. So back then we installed applications on physical servers we had in our data centers. Then we tried to add more applications on these physical servers, but then we had the problem that these servers might get overloaded and we have a conflict in resources between applications. So then we added more physical servers and installed one application on each server. That has another problem because now we have multiple servers with one application each installed, so the resources might not be used in the most efficient way. This is where virtualization came into place with a hypervisor. A hypervisor allowed us to install multiple virtual machines or virtual servers on one physical machine. As you can see on the image, we have now this hypervisor layer on the physical server, and above this layer, we have 3 virtual machines, but each of these machines runs their own operating system. And again, this is some overhead we don't necessarily need. So how can we optimize this? This is where containerization was invented. Containerization solved this issue with a new layer, which gave access to independent containers, which run the actual applications, to the physical host resources. This was very, very good because now multiple containers can run on one physical host without the overhead of emulating or virtualizing a whole operating system. But then the next question comes up when we now have multiple containers running on one physical machine. How do we actually deploy these containers? How do we manage the lifecycle of the containers? How do we repair deployments? And what happens when we have multiple physical machines with containers running on each? How do we manage this? This picture gives again an overview of comparison between virtualization and containerization, which clearly highlights that we now don't have a guest OS for each application, but rather we only can ship application code and dependencies without an additional guest operating system. From the problem of how we can manage all these different containers running on different machines, Kubernetes was announced in 2014 by Google. It was actually the third iteration of such a cluster orchestration software. And right now it's one of the largest open source projects, and it's used by almost every Fortune top 100 company. So what are the features of Kubernetes? The feature is management of nodes or servers as part of one cluster. So we can have one cluster which consists of multiple nodes. And then we can schedule containers, which are applications, or in Kubernetes terms, pods on these nodes. It has application health checks for these containers, for these pods, and also auto healing. So it knows when a pod crashed or ran out of resources and is able to fix that with a continuous reconciliation loop. This is a very, very high level architecture of Kubernetes, but I think it's really important to understand in a bit more detailed way how the whole thing looks like. Basically, we have two main parts. We have, on the one hand, the control plane of Kubernetes, which also runs inside the cluster. It provides an API server to control and configure everything that's running in the cluster. We have a scheduler, which is responsible for scheduling pods or jobs. And we store the desired state of the cluster itself in the cluster, which means which pods should be running and how many is stored in the cluster as well. On the bottom, we have the worker nodes, or which are servers. And on each of these servers, we have a container runtime, which I've showed earlier, which allows pods to be executed and scheduled on these nodes. And now a developer can interact with the API server of the control plane to schedule deployments, delete pods, create pods, and so on. Important to notice here is that pods aren't the only resources that we can schedule. We also want to, of course, deploy applications which are exposed to the internet. So we have to deploy services and storages and so on. So there are many, many different resources which we can deploy in a cluster. For simplicity, in this picture, I displayed the pods. So how can we run Kubernetes on Azure? In Azure, Kubernetes has its own service. It's called AKS, so Azure Kubernetes Service, and it's a huge product. And the special thing is that the control plane, so the API server is managed by Azure, and it integrates with many, many different Azure services. For example, usually when a developer tries to access a cluster, the question is this developer allowed to do certain operations? So we need some role-based access control in place. There, AKS integrates greatly with the identity management of Entra ID, so we can assign Entra IDs permissions to do certain operations on a cluster. We have governance control with Azure policies to enforce certain regulations or regulatory requirements. We have a private networking integration, which is very important for enterprise scenarios. So we can integrate clusters into virtual private networks and also integrate other Azure services over a private connection like databases or storages. And there is much more. Things like auto scaling and so on. Really, we could spend a whole 10-hour series on Kubernetes on Azure alone. But how do I actually deploy an application on Kubernetes? We can interact with the cluster with the kubectl or kubectl command line. And there we can run commands, which then get redirected to or call the API of the Kubernetes cluster. We can define the deployment files in a YAML file format. And then we can run kubectl apply and pass that file, which will send the request over to the cluster's API server and then perform a deployment. In our example, we will create the Kubernetes resource deployment, which will in the end run a container with the Nginx container image, so a basic web server. So that sounds really good, but what is the problem with kubectl? There's no problem directly. You can, just write your deployment files and then apply them. But when your project starts to grow, you will have many different resources and many different teams working in Kubernetes. So the question is, which applications are currently deployed in my cluster? What is the state of the deployed applications? Are they healthy? Are they not? Which versions are deployed? And also the question, what has changed since the last deployment? It's especially important when troubleshooting a cluster. This is where modern deployment processes help us, especially a process called GitOps. When using GitOps, we store configuration in a Git repository. We know Git repositories from software development, where we store and version our source code, for example, with tools like GitHub or GitLab. Now we use the similar approach for storing configuration, or in our case, YAML files. So we have a version and change history. The changes are made transparent for every team member who has access to the repository to review. And we can add approval processes and changes through merge requests so that we can have checks by our teammates so that we avoid mistakes going into production. That is the Git part. And now there's the operations part. Now, the interesting part is that the configuration from the Git repository is synchronized to our target system, in our case, to the cluster. And this is done with an operator who checks in the cluster for regular updates and then performs certain action. In our case, the deployment information is pulled from the Git repository and then sent to the API server. This process can not only be used for Kubernetes, it can be also used for other configurations, like, for example, access requests to certain code repositories. Yeah, we can build the same flow around this. From changes are made in a Git repository and then synchronized to another system. And it's a very common approach for many companies these days. Before we jump into the practical part, here a short disclaimer for my demo. I use a very simplified infrastructure setup for this demo to get the application live quickly. If you use this in production, please check the best practices for each individual Azure service you're using before running something in production, and check each individual part of the best practices. Is my security posture in place? How do I handle topics like identity? Which network access requirements do I have? Which network security requirements do I have in place, especially when exposing services to the public internet? And also, of course, what are the costs associated with these services? Because Kubernetes also has the possibility to scale and scale automatically. And then if you start deploying things, you get more traffic and you start to scale up. can get expensive quite quickly. So what do we need for the demo to follow me? You need an active Azure subscription, and for this you also need certain permissions. If you have a sandbox subscription, that would be ideal because then you could just go with the contributor access to create your Azure resources there. You need a GitHub repository. A public one will do just fine. Or you have a private repository with private key access. And of course, we need a containerized application. We won't do any coding in this session, so I will just take a prepared sample application provided by the Azure team. The whole code and configuration I'm running, so all the deployment files and commands, will be shared later in this presentation, so then you can replicate the setup on your own. So what are we going to build? This is the first step that we are going to build. So you have this three-step process. We have a developer committing a change to a Git repository. And then at the bottom, we have a Kubernetes cluster, which runs the ArgoCD operator. As we've seen earlier, this is exactly the GitOps integration. So we connect the ArgoCD operator to the Git repository, and it checks for changes in the repository on a regular basis. And when it detects changes, then it deploys the corresponding resources, in our case, containers or containerized applications, to the Kubernetes cluster. Now, I'll switch over to screen sharing and let's see how this looks like in action. So let's start with the demo. I cloned the repository of this talk, and now we go into the cluster setup, because that's the first thing that we're going to do. We are going to create the Kubernetes cluster on Azure with AKS. To create the cluster, I use Terraform to make it easier for you to reproduce my results. And as already mentioned, I also include the code in the repository, so you can try this out by yourself. In this Terraform script, I create an Azure resource group and a Kubernetes cluster. You can name it whatever you want, select your preferred region and version as well. Most important here is that I set the access control. So I created a group in Entra ID, the identity management related to Azure, and I added my user account to this group. And with this line, I set the access or the admin access to the cluster to the group my user belongs to. We can also configure the node pool. I set some values for autoscaling here, so the cluster can increase and decrease in size, so it can create new nodes on demand. But this is very limited to limit the costs here as well. I'm going to deploy this cluster now, opening a terminal and running Terraform apply. Make sure that you're logged in with your Azure account before running Terraform apply, so it will use your identity to deploy the changes. Now we can validate the plan, which resources will be created. So the resource group will be created and the cluster as we configured. This is looking good so far, so let's apply these changes. This will take a few minutes because it creates a lot of dependent resources for the cluster, so we'll be back in a few minutes. So welcome back. We took a short break. It took around 4.5 minutes to deploy the cluster to Azure. Let's check if everything worked out as expected, and let's test if we can connect to the cluster as well. We are here in the Azure portal, and we check our resource group, and yes, here's our new cluster that we just created. And here you can see already that we have a lot of different configuration options as well. And each of these, as I already said, is an own session for itself. But what we do from here is we hit connect, and then we paste these commands one by one to connect to the cluster. And then we can verify that the connection works by listing all the namespaces in the cluster. And this worked already. One thing I recommend doing when you work with Kubernetes is using a command line tool called K9s. It's a terminal application which allows inspection of our cluster. So here we can see which namespaces exist in the cluster. So these are like folders for different resources we deploy into the cluster. And then we check the pods, so which containers are currently running in the cluster. We can see that there are lots of different standard containers running from Azure. We need those to be able to connect the different nodes, to have DNS resolution within the cluster, and we won't touch these. But next up, we will install ArgoCD. To install ArgoCD, we need to run a few commands. So we first create a namespace, so like a folder for the ArgoCD deployment. And then we deploy ArgoCD. We are using the kubectl apply command as I showed earlier, which points to a deployment YAML file which is present in the ArgoCD Git repository. As we can see, there are many different resources deployed into the cluster right now. And in a few seconds, it should be done. When we now inspect our cluster again, we can see that there is the new namespace that we created called ArgoCD. And there we can see many containers are in the initializing state or are already running. It just takes some time for all the components to boot up correctly in the cluster. Once these are all running, we can quit this again, and we now need network access to the cluster. We have two options to access the front end or the website of the ArgoCD deployment that we just created. We could either expose a public service, so we get a public IP from Azure, which then routes into our cluster, or we forward a port into our local system. And we are using the second approach, which uses port forwarding. So we copy the command for the port forwarding, and then we should be able to access the ArgoCD dashboard from our local machine. Let's see. Yes, currently we are not using HTTPS. If we would deploy this for a production environment, we would use certificates and of course SSL encryption for the connection. So we are accessing the dashboard right here. The standard username is admin, and we need to get the initial password as well. So we could also configure this during deployment, but it will also create a default password for us. With this username and password, we can log into ArgoCD, and this is what the dashboard looks like. From there, we will continue configuring the Git repository and creating our first deployments. Now it's time to connect our Git repository in which we stored the application configuration so that ArgoCD is able to deploy our application. So we'll just copy the URL from the repository and go to Settings in ArgoCD, go to Repositories, and then we're connecting a repository. If you have private repositories, you might select cloning via SSH and then provide your private key. For now, we are just using HTTP, but we want to clone a Git repository. We just put it in the default project. We provide the repository URL, and then we are already good to go. Let's connect the repository. The connection status should be successful, and now we can deploy our first application. So let's create a new application. Let's call this our app1. We select the default project. For now, we want to set a manual sync policy, so we don't want ArgoCD to synchronize automatically. And then we select the repository, and we have to input a path. The path would be the path within the repository where our deployment configuration is saved. In our case, it's in this folder 03 application deployment, so that it can find this file. It will deploy any YAML file it finds in this folder. So I will just select this path right here, and it should deploy to our current cluster. Interesting here is that we could also deploy from this ArgoCD instance to a different cluster. So we can manage deployments in different clusters as well. Let's maybe select a namespace as well. So we want this to go into a new folder. Let's call it pets because our application is a pets shop application. And with this, we are almost good to go. We could also say, hey, automatically create this new folder in the cluster for us. And so let's create this application. Okay, so what do we got here? We got our app1, and if we click on this application, we can see more details. It already detected that our application is out of sync. Why is that the case? We see right here our application that this app1 is missing something, and it misses here this Nginx deployment. When we check the YAML file of the deployment, we can see that right here we defined this deployment called Nginx, and everything else is commented out for now. So this is exactly the change ArgoCD would expect to be present in the cluster, but it currently isn't. Let's synchronize this application. And when I hit synchronize, it gives me a summary, which resource will be synchronized, and then I can perform this action. Now, the ArgoCD steps into action and actually created this Nginx deployment, which in the end is a pod or a container. So when we check now back to our cluster, we can check the resources. We can see that we have a pets namespace now, so folder for our resources. And right here, we have this Nginx container. So what happens when we now want to deploy the whole application? and make multiple changes. So we are back here in GitHub. I will press dot to edit the files directly. And I will open up my deployment file. And I first want to comment out the current deployment. And then I want to add the real application. So I will scroll all the way down. Here you can see how really 500 lines of YAML configuration for a few services. So these can get huge quite quickly. I can comment those in. Now I have all these different resources here, different pods, storages, which I want to deploy. And I have to commit these changes to version control. Add application deployment. I commit and push this. And then I'll head over to ArgoCD to see what's going on there. So usually I would configure ArgoCD that it checks every few minutes if there's something new, some new change in the Git repository. I can also change manually and or refresh. And now you can see it detects that my state in the cluster is out of sync with the current deployment. And you see all the new resources for this new application. I will then synchronize these. I get a summary. Okay, my Nginx container here gets deleted and all the other services will be created. And I'll just hit synchronize. And now all these new services are starting up. And I can also check the cluster as well. There we can see that all these new containers are created. After we deployed our application, we also want to test it, make sure that it works. So therefore, we need access from our local computer. Currently, we don't expose the service to the internet, so we also use port forwarding here to access the service locally. For this, I will forward a port of the service, and with that, I can then go to localhost and I can see my pet accessory store and I can access different things here. So what happens when I now get a lot of load on my application and I might need to scale it up? Usually we can configure things like auto scaling as well, but let me show you how it works when I perform now a change to a configuration in the deployment file. For example, I can see that the order service is under heavy load and I want to scale that. So I will change the number of replicas of the service and commit this to version control. Push the changes and then head over to ArgoCD where these changes should be detected. Maybe let's put that side by side here so we have a better picture what's going on. So we have here on the right side our pods of our services, so our containers, and on the left side we have ArgoCD. When I now refresh, I can see that my cluster is out of sync with my configuration. And now when I hit synchronize, it says, oh, there is change in the order service. Do you want to apply this? And when I hit synchronize, I can see that 2 new pods are starting from the order service. They are initializing, and now they are running. There is a lot of different configuration we won't cover here today, but when we inspect how such an application in ArgoCD looks like in detail, we have here our repository configuration, we have a status, we have different container images which are used in the deployment. And here, something very important, we can also enable automatic sync. But here as well, we have different kinds of controls, like do we want to enable pruning, so deletion of resources, or do we want to enable self-healing? Depending on your scenario, it makes sense to go through each of the single configurations and find what fits your needs. Yeah, so that's it for the demo. We have a Kubernetes cluster which runs our application, which we defined in the Git repository. In the cluster, we created an ArgoCD deployment, which pulls the changes from the Git repository. And from there, we can deploy our containerized applications. Maybe we can also check here in the Azure portal if something has changed. From here, we have the same view like in this K9S tool. We have here our pets namespace, and also can see here the different pods. Now let's jump back for wrapping the session up into the presentation. So this was our demo setup, and usually in the real world, this is like part of a bigger process of developing and shipping a software product. Usually it would look more like this. We not only have a change in the deployment configuration of how many replicas we want to create or how many versions of a service we want to create. We have changes in the code as well. New features are implemented in the code before there is a new version of the app available. So this process gets a bit bigger. We have developers writing their code in their IDE, for example, Visual Studio Code. They check in their code. The code gets tested and built as well. So we have a new version of the code in a container stored in a container registry. Then we can update the Kubernetes manifest, and which is then synchronized with ArgoCD. So this would be a whole development flow from code change to actual deployment as a container in a Kubernetes cluster with ArgoCD. Follow-up topics after my talk. Yeah, before you start your GitOps journey, make sure your cloud environment is built according to best practice. Take in mind that you create a secure and cost-efficient cloud environment, but please test the GitOps approach. For me in practice, it was also really amazing to see how you can automate other things as well besides from Kubernetes deployments. Everything related to configuration can benefit from this approach, from saving it in a Git repository and syncing from there. And yeah, when you start with your GitOps journey, you will see that there are lots of tools out there. For example, there is Flux, which is a native AKS integration for implementing a GitOps flow. We use also Helm a lot to group multiple YAML files and make them reusable as packages. because sooner or later you have the problem that you want to have the same package deployed in different environments, for example, in staging or production with different inputs. And there's also Argo workflows, which allows you to create workflows with containers which run step by step and which can be observed in the UI. And there's a huge ecosystem around this whole Kubernetes deployment area. That was it from my side. Thank you so much for listening. I hope you enjoyed the demo as well. If you have questions or feedback, please get in touch. You can reach me on LinkedIn or by mail. Thank you very much and have a nice rest of the week. Bye bye.